what is unit testing and what is xUnit and why we chose this framework. So xUnit is a testing framework for .NET. So its job is very simple. So finding the test methods, run them until it is pass or fail. That's it. So xUnit does not mock the dependencies, like mocking the duplicate values, the third-party integration values, databases, like those things it won't do. And it won't do the code coverages and do assertions like magically. So assertions are still our responsibility. And why xUnit used in real projects? So companies choose xUnit because it is clean, no magic attributes like test class, construction injection it was supporting, and perfect to use with mock and coverlet. So industry standard for .NET Core and .NET 8. And the basic syntax for this xUnit, how we going to implement in our project. So it is using AAA pattern. So non-negotiable, it should be same like this: arrange, act and assert. So arrange means setting the data required for that method, and act calling the method services like that, and assert, so verifying the result with the returned values. So this is the example. So fact, it determines that it is a test method, and this is our test method. We are arranging values and doing act and assert. So here we are comparing the result. It should be 30. So what is unit in your roadmap? That we will see step by practically. To explain and understand this kind of xUnit concept, we have created order API. So not only order API, order application. So the business logic, which contains the business logic, and order infrastructure, which will have the infrastructure, data access layer, class libraries, like those things. And we have order.test to test the project. Then we have added the references. So we have added the order API reference to order application, same as well as order infrastructure to order application, order test to order application. So this purpose is we have added order API to order application to allow all API layers to use application service and business logic, and order infrastructure, enabling the infrastructure layer to implement application interfaces and contracts, and order test, allow the test project to test the application layer components. This is the dependency graph. Order API, we have order application, order infrastructure, access to order application, order test, access to order application. Next task, to install the necessary packages. So here we are going to install the xUnit package. It was included already in our project, and then we have verified that xUnit runner.visual studio it was installed or not. So it was already included in xUnit test project. So this purpose is to Visual Studio test runner integration for the execution test in our IDE. For more details, like so why we need this runner.visual studio, so it allows us the Visual Studio to discover and run the xUnit test cases. xUnit alone is not enough for our Visual Studio UI. So this is one additional package. So why we need it? So without this runner Visual Studio, Text Explorer show no test, and run debug test buttons don't work. So you will think tests are broken maybe. So using this package, we can test appear in a Text Explorer separately, and run and debug from Visual Studio itself, and works with our breakpoints as well. We can debug and works with in CI pipelines as well. Next we have installed this kind of package FluentAssertions. So this was installed with this command .NET add package FluentAssertions. So this purpose to provide more readable and expressive syntax for writing assertions. For example, see this example, like so here instead of writing our xUnit basic syntax, we have to write something like assert equal 200 with the result. So instead of that, we can do something like that, result should be 200. So that will be more fluent, like our normal English. We can use this as like a readable English. The exception message should be contain this quantity, order should not be null. So anyone, even new joiner, understand the test instantly. And then we can handle better failure messages. If your test fails, FluentAssertions tells you expected value, actual value, and exactly what went wrong. So this saves our debug time as mentioned and less noise. For example, without this FluentAssertions, so like we have to write assert not null order and assert equal, assert true, something like that. But using this package, we can easily write in normal English like order should be not be null, order quantity should be 2. So we can use this kind of way, clean and intent. And this is optional one, we can use this for our better handling. Now we have created a first class like calculator test, just one sample class, and added a sample method here just to adding the two numbers, and applied the pattern Arrange-Act-Assert, and we have given the class for that calculator. Next we are going to update our order application. So for that I have created order model. On that I have a product ID, quantity, price and total amount. Then I created order service. On that we have order service class, and I have a decimal return method calculate total, so which receives decimal price and quantity, two parameters. If the quantity is less than 0, we are returning an exception, quantity must be greater than 0, otherwise we are calculating and return the value. Now we are going to test our order service calculate total method, so which takes price and quantity and multiplies it and returns the result. So here we have written 3 methods to test that. So first one, when we are providing valid quantity, so it should return correct total, that is the first one. And here we are arranging with our values, like we are providing price, quantity, and we have set the expected value here as well by calculating this, and we are calling this method, assigning the values, and we are using this result should be expected value, so that means 31.50. and then when quantity is 0, it should throw argument exception. So here arrange, like we have arranged the values, quantity is 0, so we are calling that method, and act should throw argument exception with message quantity must be greater than 0, and then calculate total, when quantity is negative, it should always throw exception. So we are calling that, and we are assigning the values. Here quantity is -5, and we are checking that quantity must be greater than 0 exception. Let's try to run this application. Starting the test execution. So it's passed, failed 0, passed 5. So it's all good to go now. Now I have created order repository interface. to get the price and save the order. We are going to use in-memory database. We are going to use in-memory database, and I have created iDiscount service to apply the discount. So it receives the amount and the quantity, and it will have the logic that we have to implement. And order service we have implemented here. We have updated that, like process order. So process order receives this int product ID and int product quantity. If the quantity less than 0, it will throw the exception and fetch the price from the repository get price and calculate the base total, applying the discount and creating the order and saving the order to in-memory database. And in our order service test class, we have created these two repositories. One is stub order repository and one is stub discount service. So why we need that? What are stubs? Stubs are minimal implementation of interface used in tests. So they are satisfy the interface contract, so the code under test can run, but they don't perform real work. If you see here, we are mentioned the two methods here, and in the discount service we have mentioned the two interface that what we have in our order service. So why we need this? So after refactoring the order service to use dependency injection, the constructor requires iOrder repository and iDiscount repository service. So the existing test only exercise the calculation total, which does not use these dependencies. So we need these steps to instantiate the order services. Previously we directly accessed the order service. Now we have to access through the interface. So instead of accessing the direct interface, we are using this mediator. So in this place I have installed the mock. I have installed the mock package, and I am going to implement this mock in our test project. So first let's see about this method. When valid input provided, returns price from repository. So here first we are creating the mock repository. So we are creating a fake implementation. If you see here, we are creating a fake implementation, and then real DB or services will be not used because we are going to control the exact behaviors. And test data setup. So we have set up the test data. So whatever DB calls or something else required, so we will set up the values here. We will directly hard coded the values here. And mock behavior setup. So repository mock. So if you see here, we have set up the mock repository. So what happens here is, like mock repository setup get price product ID. So actual behavior, this get price will call the database and retrieve the value. So instead of calling the database, we have set the value here, product ID already. You see here, product ID we have set the value, and so the expected value. So get price something, it will return a value. Based on that we will process something. See here, expected price we already set that here. So here no real DB logic, we are just only using the hard coded values. And a discount service mock. Next one, we are mocking the discount service. Apply discount. apply discount, we have mocking that value. So based on this input, actually it returns this discount total. We have already set the value here. If discount is applied for total quantity 3, so it will return the value of 30. We have given here both, so base total calculation and the quantity as well we have given, expected price as well we given, and based on that value we have given the discounted value here. We have set the value here already. Next jump to this line. So what is really happening here? So we are doing a dependency injection here manually because the order service need dependency injection. So we are saying order service, I am not giving you real dependencies, I am giving you controlled fake ones. So if you see here, this order service need 2 parameters as a dependency injection. So it is expecting 2 interfaces and it's doing dependency injection in actual behavior. So we are giving our mock repositories that we have created here. So we are giving a mock repositories here. So that's what we are saying here. So what order service looks like actually. So actually it looks like this. So order service depends on interfaces, non-concrete methods. So we are providing the mock repositories that we have created. So next, this act line, we are calling the order service process order. If you see here, so only one method call, no branching, no logic inside the test, and assertion. So we are doing the assertion. So whatever the value we have given, we are doing the assertions with the equal value that we have given. Let's do a quick recap. We have installed the mock framework, installed the mock nougat package, ordered test, and enabled the mocking capabilities for unit testing, prepared for advanced mocking scenarios and implementations. Like we have created the test cases. So when valid input provided, returns price from the repository. So verifies the price, it is correct, fetched from the repository. So we have mocked the values, we have mocked the interface repositories, and we have mocked the we have given the hard-coded values, and we have written the values without calling the database from get price. So assertions here, order return is null, product ID matches, quantity matches input, so price matches, like those things we did. And then save method called once. So verifies save order is called exactly once. So here Times.Once. So using Times.Once to verify the exact call count. Why it is any order that we have used here. So we don't care about object details here. You care about the call concurrency, and that's correct separation of concerns. So it's behavior kind of a test case. So in verification we have few things like Times.Once means correct behavior, Times.Never conditional logic not trigger, times at least once retry loop scenarios, times exactly batch loop logic. So next, this method, when order processed, save method call with correct order. So you see here we have this process order in our order service. So process order, what it's doing, I'm telling this again. So getting the price, applying the discount, and creating order object and saving that into DB. So for the same method, we are doing different scenarios test cases. So what this method, save method, called with correct order does. So this method, when an order processed, the order repository must be called once with an order containing correct business data. So this validates the data integrity plus behavior. Step-by-step explanation. So we are doing arrange. So we are doing mock the repositories. We are providing the input and expected values. And as usual, mock behaviors, we are calling the get price. Price comes from the repository. Discount modifies total. And doing act single call clean unit test. And the assert predicate based verification. So what's happening here? So we are saying save order must be called once, and the order passed to it must match all the business rules. So save order we are giving here, and this part should be called only once, and as well as we are providing whatever value, like the order passed to it must match the all business rules. So this verifies the correct data manipulation, calculation, and discount application. Next we have returns discounted total. So what it does? So when a discount applied, process order must return a total lower than the base total and equal to the discounted value. So as usual, we have mocking the repository, arranging the value. Here we are setting the price and base total and the discounted total. So we are here, we have applied 15% discount, and here we are giving the base total, price, and to quantity. So price here it is 20, and if quantities means 100, so 15% we have reduced here, and then we are arranging it, and price source is controlled. You are not testing the discounted logic, only its effect. And we are doing the business rule verification here. Result total amount should be discounted total. Result total amount should be less than base total. So business rule enforced here. Discounted rule reduces the total. This second assertion is very smart. And the next method very simple. When no discount applied, returns base total. Very simple. We are arranging the mock repositories and have set the value, and we have set this price 10, and we have set the price and the quantity equal to 2. So 100, if we calculate this price 10 into 2, so it will be 20. So the base total should be no discounted value. So we applied the base discount value to discounted total. So as usual, we are calculating and apply discount. So we are processing the order, and we are doing the assert here. So result of total amount should be base total. Result of total amount should be, so we have even manually given the value here. More techniques that we have used: setup, returns, verify, time once, it is any, matches any parameter value, it is, match specific parameter values with condition. So more verify technologies that we have in mock. Some examples like time once that we have used: time exactly, called exactly and times, at least, at most, never, called, between, minimum and maximum times. And is any, like match any value of type t. So like those things we have.